was asked to help write the ecology report for what was then going to be the world's biggest landfill site. During that task, I came across rare pitcher plants and Burmese pythons. Now, these Burmese pythons have a party trick. And the party trick is that they are capable of swallowing a pig whole. Now, if you don't believe me, after this session today, this afternoon, go and have a look on YouTube. And there are a couple of videos about it on YouTube, and it's absolutely mesmerising, because you see the size of them and then you see the size of the pig. But I would suggest you don't actually watch it whilst you're eating anything, because it might put you off your lunch. So anyway, I came across these lovely, rare and fantastic fauna and flora. But during the weeks that followed, two questions kept bothering me. And the first question was, how much of the waste going to landfill comes from my industry, the construction industry? And the second question was, how can we reduce that? Now, fast forward 25 years, and the construction industry is responsible for generating 5 times as much waste as the household sector. And 6 million tonnes of that non-hazardous waste still goes to landfill. Now, let me put that into perspective for you. Imagine the weight of one double-decker bus. Now, multiply that by 400,000 and you have 6 million tonnes. So the equivalent of 400,000 double-decker buses going to landfill every year. It's shocking, isn't it? But that's not the only problem. When we build new structures, the construction of those new structures emits greenhouse gases. And that's through the manufacturing of the materials that goes into the structures emits greenhouse gases, plus the construction process itself. For instance, cement, which is one of the largest ingredients, which is one of the main ingredients in concrete. The cement industry produces over 5% of the world's greenhouse gases. So I'd like to share with you today some of the solutions that we've come up with on our projects for reducing waste and reducing greenhouse gases. Now, opportunities to reduce waste occur throughout the design and the construction process. But the biggest opportunity occurs right at the start, at the outline design stage. The potential for change reduces as more and more of the design elements get fixed. And as those design elements get fixed, the cost for change increases. And along with that, there's an increase in the resistance to change. What we like to do at the start of a project is carry out a DARE workshop. Now, DARE stands for Design for Resource Efficiency. And so we invite the client, the architect, the contractor, if they've been appointed that early in the project, and we get them all together. And the DARE tool helps them. It has a series of checklists which really helps them get the creative juices flowing around a number of resource efficiency topics. So, for instance, it gets them thinking about how can they reduce carbon, how can they reduce water, energy, materials and waste. But first of all, we look at how can we avoid building altogether, or avoid building certain elements of the project, or avoid bringing or reduce the amount of new materials we bring onto the site. An example of this is anybody who's travelled on the A303 between Sparkford and Ilchester, not that far away from here, knows that the traffic bottlenecks before a series of single carriageways. We were asked to look at that. Now, the offline solution would have involved actually designing a brand new dual carriageway through the surrounding countryside. But our engineers looked at that and they thought, well, actually, we can make use of what's there of the existing carriageway and just widen it to avoid building a brand new structure. And in doing that, we were able to reduce the carbon emissions from that construction process by 45% from the original dual offline solution. In the same project, we also looked at changing the drainage design. So we changed the drainage design from pipes to open channels, because open channels don't need to be dug up to be repaired or replaced, and therefore you avoid the maintenance emissions which comes from digging up pipes. The scheme also had flood storage ponds to store the flood water when it rains. And what we did was we actually planted reeds. We designed it so that there were reeds planted around the flood storage ponds, and that increased the climate resilience of the project, because it was then capable of storing an equivalent of an additional 40% additional rainfall, or an increase of 40% in rainfall. So if you can't, but the next best thing, if you can't avoid building altogether, is to look at reusing what you've already got, reusing your existing infrastructure. Or if you can't reuse your existing infrastructure, try and reuse the materials that you've already got on site. And two examples of that. In the first example, in Cambridgeshire, we were asked by the client to design a system to transfer water between Rutland and Grafham. Now, the conventional solution would have involved building a brand new 37-kilometre pipeline, which would look something like that during its construction. A brand new 37-kilometre pipeline, which would also have crossed a number of sites of scientific special interest, or SSSIs. Really, that was not an ideal solution. So our engineers had a brainstorming session, and they noticed that there was actually a pipeline already there. It was redundant, but it had been used to transfer water in the opposite direction. So they thought, well, maybe we can reverse the flow of water. So they did a little trial. They reversed the flow of water. It worked. So we were able to reuse that existing pipeline to transfer the water to where it was needed. Another example, in North Wales, Colwyn Bay. The client had a promenade which was getting old and it wasn't attracting many visitors. So they asked us to redesign the promenade to attract more visitors to the area. And we looked at this and we held a DARE workshop where we invited the client and we invited the architect. The contractors hadn't been appointed yet, so we couldn't invite them. But we then had a discussion and we identified that the client actually had a lot of materials sitting in a depot which had been left over from previous projects. And they were just sitting there. So what we did was we designed the new promenade to include those materials in our design. So avoiding having to ship new materials to site and all the greenhouse gas emissions that would have been involved with the transport and the manufacturing of the materials themselves. And secondly, we had to dig up the pavement material to build the new promenade. And initially, we thought we would have to dispose of that. Now, the material contained coal tar, which is a tricky substance to reuse, and the disposal costs of that would have been £300,000. So we spoke to our pavements team. Yes, we have a pavements team. and the pavements team came up with a solution. They said, let's bind the coal tar with some other materials such as water and aggregate in a process called hydraulic binding. And that process enabled us to reuse that coal tar and that material and relay it as a subsurface layer. So again, we avoided bringing in new material and we avoided the £300,000 disposal costs at the same time. Now, if there's anything I'd like you to go away with today, it's this. It's this. One thing. If you're involved in a project in the future, maybe as a client, as a member of a project team, or as a stakeholder, maybe as a member of a public in a stakeholder engagement exercise for a new project, please do ask the design team, because you'll have that opportunity. Ask them, have you done everything to avoid building elements of this? Have you done everything that you can to reuse what's already there? Because if we take time at the start of the project to really think about these matters, we can avoid sending material to landfill, we can reduce greenhouse gas emissions, and we can reduce the costs. So, in the words of Benjamin Franklin, take time for all things, because great haste makes great waste. Thank you.